Hello everyone, I'm Digant Kumar from grade 9 and these are my fellow team members Aditya Singh from grade 7 and Shreya Singh from grade 8. We are the Green Innovators representing NPS International School, Guwahati. We are here to talk about our project Smart Irrigation System, or in short form SIS. For more details, let's go over to Shreya.
Smart Irrigation System, also known as SIS. Smart Irrigation System growing tomorrow's harvest today, presented by NPS International School for better tomorrow. Introduction. Project name Smart Irrigation System, target industry, farmer industry. Mission statement: we are providing guarantee that all the farmers out there will be helped by our newly developed project named Smart Irrigation System SIS. For more details, over to Aditya.
So, the components used in our projects are as follows. In total, there are 8 components. Number 1, Arduino Uno R3. Number 2, jumper wires. Number 3, 12 volts battery. Number 4, motor. Number 5, motor driver, which is L2789. Number 6, servo motors. Number 7, radio frequency 433 MHz, which has a range of 50 meters. And the other components are there. For example, the IC HT12D and HT12E for the communication part, along with Bluetooth communications. Over to Digant for more.
Thank you, Aditya, for your explanation. Now, so you might be wondering, what is the objectives of our project? So the objectives of our project are as follows. It is to provide a safe and efficient way to combat the water wastage that we see all over in the news, and then we know from our own experiences. Our objective number 2 is to provide a cheaper way to manage an entire field's resources at a single glance. And the third objective is to step into a more sustainable way to farm our food. And lastly, it is a simple yet powerful and easily understandable tech product. So, numbers don't lie. We heard this term already, but now the actual numbers are here. We did our own calculations, and via our research, SIS Smart Irrigation System can save up to 16.25% of the farmer's resources in the long run, and if they use it continuously, it will save an additional 6.2% of their overall water usage. Now you might be wondering, there are such other techs in the market which are similar, if not different from this, but still perform the same function. Well, we took that into account. As you can see, a Smart Irrigation System SIS has the compatibility, which means you can change whatever you need, how much water you need and how much soil moisture you need. We have that, but it is not found in traditional irrigation system and not found in other smart irrigation systems. And then we have automatic turn on, which means it will go on its own forever unless stopped. We already have it. Obviously, traditional does not have it. And in smart systems, it's limited to certain degree. And also live action, which means you can visually see what is going on in the field, which means you can see how much water is going, how much soil moisture is there, etc. We obviously have it. In traditional, we don't. And in smart irrigation, again, it is limited to only how much water you can give. Now, if you don't believe me, all these claims might sound very vague and very exaggerated. So, to show you that these claims are actually real, over to Aditya.
Thank you. So, now I'm going to explain how this whole project works. Basically, this project used 2 kinds of communications, radio frequency communication and a Bluetooth communication. The radio frequency, we have used 433 MHz receiver and transmitter module, which has a range capability of 50 meters, along with the Bluetooth module, so that we can connect it with our app if developed. So, here are the chips, and this is continuously monitoring the data from the soil moisture sensor and sending it to the main tower, which is the receiver. Here the tower is receiving all the data from the soil moisture sensor sent by the transmitter and measuring if any of this field requires water. Here we have set 2 examples, one dry land and one fully watered land. So now, this whole system also includes different other components, mainly the Bluetooth module, and the Bluetooth module we have included so that we can connect it to the app, and that app can also control how much water it should spray. For example, different crops require different amount of water, like paddy or any kind of other crops like maize. So we have also set an app so that it can be used to control the amount of water that will be flown. The app includes AI, which is more helpful for measurement of the water required. So for the working process, now as I had explained that this field is dry whereas this field is properly watered. Now I'll turn the tower on. This is automatically connected. Now automatically this will spray the water until the land is properly watered. The chip is sending all the data and telling the tower how much data has been sent and how much moisture of the sand is being sent by the receiver. Now as the land is properly watered, as you can see that everything is turned off. Now the sensor is detecting how much soil moisture is present in the soil, and once it has reached the capacity required for growing the crops, it has automatically turned the whole system off. Now the main thing of our project is how does it get its power source. The power source is its solar panels, the renewable form of energy. In the daytime it charges itself, and even if required at night it uses battery and cells to automatically power all the devices. And we have also developed an app for this particular project to demonstrate how it works. Over to Digant.
Thank you, Aditya, for your explanation. Now, as he was talking about an app, so here's the app. SIS user interface. So he was talking about customizing how much moisture level is required for each crop. So we have it here: paddy, maize, rice, and millet. And if none of your options suffice, you can enter your crop here. For example, if I wanted corn, let's see, CORN, corn, and select it. The AI that is inbuilt in this app will automatically check online for the moisture required, how much time it requires, and how regularly it requires for each plot of land this device is in. Right now it's in its rough phase, but it is still functional and does all the claims that we have made.
Now I'm going to explain our future goals. So number one, to make this IoT enabled product available to every farmer or Internet of Things. And number three, to help make change in the world, ever-changing world, and combat wastage.
We would like to thank our school and Niti Aayog Government of India for giving us a beautiful platform for our innovation. Thank you.